Hello, Pre-Algebra. We are going to be talking about exponents today. So before we started into this continued learning, we had finished up chapter 3 and you took a test on it. So we are moving forward to chapter 4, and today we're going to be talking about 4-1 exponents. So if you would please go ahead and head your paper 4-1 exponents. There are 4 vocab words for you to write down in your notes, and please get those definitions. And pause your video right now so that you can go ahead and do your heading and your vocab, and then when you're ready, start the video back up and I will talk about those for you. Alright, so now that you're back, the first of our definitions is exponential form. What that means is you have a number that's in exponential form. You have it written as a base and an exponent, which might look something like this. The exponent is your little number that's up high. That tells you how many of the base you have. Which you're multiplying. How many of the base you are multiplying? I really miss my smartboard where I can just slide it over a little bit. Your base is your big number. That tells you what number you're going to be multiplying. A power is a number that's taken to an exponent. So our 2 to the power of 3, that's considered a power. The answer, which would be 2 times 2 times 2, because we're multiplying what our base is, the 2's, and we have 3 of them because our exponent is 3. The answer to that would be 8. So both 2 to the third and 8 are considered to be powers. They're both numbers that are considered having a relation with exponents. This one is written in exponential form. This one is written in standard form, but they both represent a number that is in fact a power, 2 to the third. The other thing that I would like you to add in your notes before we get to the examples is how to read these or talk about these. What I want you to add to your notes here is that, just like I had read that one, if you have this, you could say 2 to the third power, or you can say 2 to the power of 3. So you can say it either way, 2 to the third power or 2 to the power of 3. There's also a special name when your exponent is 3, which is cubed. So a third way we could say this one is 2 cubed. The only other exponent that has a special name for it is actually 2. So if we had this, we can say 5 to the power of 2, or we could say 5 to the second power, or finally we can use a special name, which for an exponent of 2 is squared. So the last way you could say this one is 5 squared. I also want you to make sure that you have these in your notes. If I'm going too fast for you, this is kind of a handy situation because you can feel free to pause the video anytime you need to copy stuff down. So anytime I'm giving notes or example problems, if you need to, listen to me while I talk it through, then pause it and write it down in your notes, and then start the video again. This is actually kind of handy that way. So the next thing that we're going to do is go through the examples for this section. I'm going to give you all of the examples, and I do want to see these in your notes. So example 1, you have numbers that are written in standard form that are being multiplied, and you're supposed to simplify that and put it into exponential form. Here's what that means, and I'm sure you guys have seen this before. You are going to take 5 times 5 times 5 times 5 times 5 times 5 times 5 and simplify that and say, okay, we're multiplying 5s, and you have to figure out how many 5s you have, which if you count them up, there are 7. So we would say 5 to the power of 7 or 5 to the 7th power. Another example is take -4 times -4 times -4. In this case, we are going to have to keep those parentheses showing that -4 is what our base is. And I'll show you in a second why that is. But we say, okay, we have 3, -4, so we would have -4 cubed, or -4 to the power of 3, or -4 to the 3rd power. Any of those ways are fine. The reason that these parentheses are so very important is that when you have a negative with an exponent, so we have our base number being a negative, in order for that negative to be included with our exponent, you have to have parentheses around the -4. So we are going to take, I'm going to take a different example and say we have -3, and we are going, we're going to cube -3. So if I have those parentheses, this means -3 times -3 times -3. If we do a negative times a negative, that's going to be positive. Positive times a negative would be negative. So then we can think about our numbers, and we do 3 times 3 is 9, times 3 more is 27. If we were to not have these parentheses, in this particular case, we would have that negative floating out in front, and then we would do 3 times 3 times 3. So our answer here, you can see, is the same. The issue happens if you have an even exponent. So watch what happens if I change this exponent to be cubed rather than, I'm sorry, squared rather than cubed. So if we say here, I have -3 times -3. Well, negative times a negative is positive. 3 times 3 is 9. So that answer would be 9. Look what happens down here, though. We have -3. The squaring is just on the 3. It doesn't include this negative out in front. So we put a negative out in front, and then we have 3 times 3. Negative times positive is negative. 3 times 3 is -9. So here we have 9, here we have -9. Two very different answers. What I would like you to add in your notes here is that the exponent belongs to only, oops, what is directly to its left. So when we say that the exponent belongs to only what is directly to its left, directly to the left of this exponent is the parenthesis. What that means is everything in the parenthesis is being taken to that power. Down here, directly to the left of our exponent, is the 3. So the only thing that's being taken to that power of 2 is the 3, not the negative that's floating out in front. You need to be very careful when you have negative bases. If you mean to include the negative in your exponential form, you need those parentheses around it. That is saying that we're taking -4 times -4 times -4. If you did not have those parentheses, you would be saying that you have 4 times 4 times 4, and all of that has a negative out in front of it. So you need to be very careful with those parentheses to include them where they're needed. The next problem here is example 2. Example 2 is taking numbers that are already in exponential form and you are simplifying those. So if we had 3 to the 4th, we're saying that that is the same as 3 times 3 times 3 times 3. So we have 3's that we're multiplying, and we have 4 of them. Our exponent tells us that we have 1, 2, 3, 4 3's that we're going to multiply. In this particular section, you need to then simplify, so you need to get an actual standard form answer. I like to do these almost like a factor tree. It's like the reverse of a factor tree. So here we're saying 3 times 3 is 9. Here we also have 3 times 3, which is 9, and then we need to multiply. 9 times 9 is 81. So we can say that our simplified version of 3 to the power of 4 is 81. The next example has a fraction. So we're saying 1/4 squared. What that means is our base is 1/4, and we have 2 of them. Don't forget how we multiply fractions. You're going to multiply across the top, multiply across the bottom, and you get your answer 1/16. Let's see, then we have -8 squared. The -8 is in parentheses, which means our base is -8, and we have 2 of them. Negative times a negative is positive. 8 times 8 is 64. So our answer there is 64. And finally, we have a negative number, but no parentheses. So remember that that means our exponent only goes to what's directly to the left of it, which is that 2. So we have the negative that's floating out in front, and then 2 times 2 times 2, which would be, let's see, 4 times 2 is 8. So we would have -8 as our standard form answer. The next example, example 3, we have, let's see, x minus y times z times y to the z power, and we are told that x equals 20, y equals 4, and z equals 2. When you're doing these, I really do want to see you write the original problem and then what our values are for our variables. The next thing that you would do is substitute in for all of your variables. So we can say 20 minus 4 times 2 times 4 to the second. And now we're going to need to remember our order of operations. So parentheses, exponents, multiply and divide left to right, and subtract left to right. So we are going to put those order of operations to good use now and look at this whole thing and say, well, what do I need to do first? I need to do my parentheses. So I'm going to solve everything that's in there. Everything else can just get copied down, and then I look in my parentheses. Do I have more parentheses? No. So the next thing I would do is this exponent. 4 squared would mean 4 times 4, which is 16. So carry everything else down. I still have these parentheses that I need to solve something in. So I'm going to do that. And 2 times 16 is 32. Now within my parentheses, I don't have anything else to solve. So I'm going to go ahead and move through my order of operations and say, well, do I have any more exponents? No. So next I need to multiply and divide left to right. So I'm taking out my multiplication and division sensor and going until I find that multiplication. I'm going to do that and say I now have 20 minus, that's a minus, 128. So notice it's a smaller number minus a bigger number, which we can in fact do because we know about negative numbers. So when I do that, I'm thinking 20 plus negative 128. I have different signs, so I would subtract. I have 108. It's negative because my negative number had the higher value. So my answer there is negative 108. There's one more example, which is example 4. It's actually pretty similar to a problem like this. What it is doing is using a formula rather than just giving you some random expression. It's giving you an actual formula to use. So they're talking about geometric figures and saying that the number of diagonals, which if you think about square, these would be your diagonals. They go from corner to corner. So there would be 2 diagonals there. If you think about, let's see if I can make a decent pentagon. Oh, not bad. Think about a pentagon. Your diagonals go again to opposite corners. So you end up with 4 diagonals there. When they give you this formula, which they do, they say that the formula of an n-sided figure, so n is going to represent the number of sides the figure has. Okay, so the formula for an n-sided figure is 1/2 times n squared minus 3n. And they have asked us to figure this out for a 6-sided figure. So we're going to just take this formula. We have one variable, which is n, the number of sides, that we're going to plug in for. They said to use 6. So we have 6 squared minus 3 times 6. We need to think of our order of operations. So we're going to solve what's in our parentheses first. Go ahead and look in your parentheses to solve that. We need to do 2 things. We need to do this exponent and we need to do this multiplication. And they don't really affect each other yet, so we can go ahead and do both. And then we need to do this subtraction. So I'm going to say 1/2 times 18 is 9. So in a 6-sided figure, we would have 9 diagonals. Looking at, just when I use it on these as well and see if it worked. So with a pentagon 5-sided shape, we would say 5 squared minus 3 times 5, which would be 25 minus 15, oops, which would be 10. 1/2 or half 10 would be 5. So that feeling like I forgot one here. I'm not seeing it. Oh, where it's right here. There we go. Knew I had forgotten one because there should have been 5. So we got that one okay. This one we would do 1/2 times 4 because we have 4 sides in the square minus 3 times 4. So we'd have 1/2 times 16 minus 12, which is 1/2 times 4, which is 2. And of course, we do have 2 diagonals in a square. So there are three examples for how this formula works. Figure out how many diagonals you have in an n-sided figure. And you could, seriously, you could plug in 100 for 100 sides and it would tell you the right answer for how many diagonals you have in an 100-sided figure, which may sound silly, but in geometry in high school, you'll actually use that for some good purposes. So now that I have gone through this lesson, I am going to assign you some problems to do. So you're at the end of this, you should have your heading, you should have your vocab, you should have notes, you should have examples copied, and feel free to go back and watch the video multiple times or pause it and write things down as you need to. And then you're going to do the assignment, take a picture of it, either email it to me or better yet would be to submit it through Rediker. And I will look at that. I would like you to turn it in by noon tomorrow on Wednesday. And then after noon tomorrow, I will post a video going over the answers so that going into Easter break, we're done with this section. After Easter break on the 20th, I'll have another video for you of 4-2.